We start the recording. Okay, so this is one of the scenario for data processing. Here again we are using this numpy and pandas we imported here as np and pd, then importing a data set. If you see on my file section, we do not have any data yet, so we'll upload it. Data.csv. Okay, here we uploaded. Now taking care of missing data, so for that we are using simple immuter from sklearn. Then simple immuter missing value we are treating as uh, numpy.nan, not a number, and strategy we are looking as mean strategy, which will replacing value with the column mean. Okay, so wherever there will be a missing values, we will take a column mean of that column and it will replace it. Okay, then we are assigning this x-axis immuter fit underscore transform, and we are transforming this x-axis whole rows whole column, and here first and second row only apply immuter to column 1 and 2 index based slicing. So let me run, and here we are printing the value of x means process features and dependent process y. So here we can see these are the values, right, which we see. We have not made anything. This is the same one as our data. Okay, so compare. This is our country, age, salary. Three three columns are as our x axis value, and this dependent is y axis. No, yes, no, yes. So this is a simple one. We have not made anything, just we fit those values. Fine. And if you see
Yes, sir.
here, for example, on this Spain country, it automatically assigned this value, right? In
Yes,
data
sir.
it was blank, correct? So it calculated the mean of this column and assigned this. Similarly for this Germany column, if you see that it assigned this value, right?
Yes, sir.
So this is for missing value. If there any missing value and you have to perform some operation, so we can use simple imputer. So data processing part now clear to you?
Yes, sir. It is clear. So
Okay.
like means there will be like what we can say like means to fill that missing data, we only have to use that mean only, or else any like is there
There
any option other?
there are many strategies. Okay, let
Okay.
me over. There are mean, median. Okay, it's not populating. Okay, no issue. We'll see in our future sessions as well. So there are many ways, like as a mean, median, two, three ways. Other method also there. So here we use the mean one. Fine.
Yes, sir.
Okay. So three scenarios we saw for data preprocessing. Now we will apply the algorithm now. So we will come to the regression part. You know about regression? It was on mathematics.
No, sir.
Okay. Let me replace all. So what is This is a simple linear regression, or we call as a linear regression. Okay. Simple linear regression is a supervised machine learning algorithm. So we saw three types of machine learning algorithm introduction at the start, right? Where it is supervised, unsupervised, and reinforcement, right?
Reinforcement. Yeah. Oh, yes, sir.
So simple linear regression is a one type of supervised machine learning algorithm used for predicting continuous target variable based on one or more input features, also known as independent variable or predictor. Okay, we call as independent variable predictor, or it is also called as a features. The relationship between input variable and output variable is assumed to be linear. Okay, so what we are predicting here, the input variable and output variable, its representation should be in linear, meaning the prediction is based on a straight line linear equation. We'll see this graph once the program will run. So this definition is clear.
Yes. Yes, sir.
Okay, so this is a linear regression. Oh, there is one more statement here. In simple term, linear regression fits a linear relationship between input feature x and output y. Okay. The model predicts the value of y as a weighted sum of the input feature. So based on input feature, it will give us the uh, predicted output. Okay. Let me show you this program. So here, this is a simple linear regression example. We are importing NumPy, we saw already. Pandas, we also saw already. So there is a matplotlib. So this matplotlib is for visualization purpose, like we have to show in a graph or in some other format. So for that we are using matplotlib library, and from that we are using myplot and taking as a PLT. This three import section is clear.
Yes, sir.
Now importing data set. So here we need a different set of data we do not have, so we'll import that. Okay, I have imported. So here we are accessing a data set. Then for x-axis, this is an independent variable, year of experience. So if you see this, we have not provided any column and rows. So it is whole rows, whole column. But here, last column, we are excluding from this x-axis value. So this will be the x-axis, and y-axis like dataset.alt ilog, whole rows, whole column, and only the last row we are taking as a dependent. So here will be the year of experience, here is the salary. So let me open this data set. So this is the data set, year of experience and salary. We have only this many data. Okay, if we want to filter two columns, year of experience and salary are there. Now again we have saw this model selection. So splitting the data set into training set and test set. For that we are using sklearn, importing model selection, and from there we are taking train test split method. So yesterday we saw it, right? X
Yes,
train,
sir.
Y train, these are just a variable name. From this X and Y which we are giving here. Test size 1/3. You can give like this as well, or you can divide 1 by 3, whatever the percentage will come. So I think it is close to 3.33 something. Okay. Random state 0. So we saw the seed function earlier, right? When we were covering the Python.
Which function, sir?
Seed, 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 seed function. Use of that.
Okay.
Any idea?
So actually, we haven't used it, I think.
We have used it. Maybe we are not able to
Okay.
recollect.
Okay,
So
I'm not able to recall it, I think.
we have used the random module, right? You remember?
Yeah, random integer. Yeah.
So,
Uh,
so random, it was predicting us the random values every time, random values. So we have to fix it. So we have
yes.
to use this seed function. So what this seed function do? Once the value is randomly generated, it will keep that value for future use also. Okay, it will not randomly generate every time. So similarly, this random state equal to 0 do the same thing. It will take the data 0.333% from this data for testing purpose, and once the data is generated on random basis, it will keep those data for future use as well. Okay, that will not shuffle those randomly generated values. Fine.
Yes, sir.
Then feature scaling, we saw if needed we have to do. Feature scaling is not typically needed for simple linear regression, but if you want to apply, we can. So again, sklearn.preprocessing standard scaler, we have took an instance of standard scaler as sc underscore x. Then whatever the standard scaler, we are transforming fit and transform, passing the value of x trace for training purpose, storing into the same variable, and same x transform dot here y x test. First is x train and second is x test. So fit and transform the training set and transform the test set using the same scalar. So this line of codes are clear.
So could you please repeat like it in short ones, please?
Okay, so what we are doing a feature scaling, or we call as a scaling as well. So this is a standard scalar which we imported from pre-processing, and what we are doing, we have splitted our whole data into two parts, one for training and one for testing. So for training x-axis value, we are using fit underscore transform method, and for training the test axis value, we are using transform method. Fine.
Yes. So actually, I just want to ask question like what thing means in our that last question,
Hmm.
we are just training and testing the y means that y variable means that dependent variable. So and here we are training x like it's an independent no. So means I just want to ask how to identify like which like we can say, like which variable or else which section we have to train like y or x like independent or dependent.
No, majorly we train x. Let me open those codes as well, so it will be easy. For data processing, what you're saying, right?
Yes, sir, that starting.
Okay.
I think we are training y on that.
No, no, I will show you those codes. Okay, so I am just keeping here to make a separation. This is the one of the code from pre-processing. So if you see here, X only we are doing. Okay, this code is clear. Like if you see here, we have doing the fit and transform X only. And here we
Okay,
put
okay,
the
okay,
label
okay,
encoding, not the
okay. I think
because
the y.
y-axis
Okay.
there was non-numeric data, right?
Yes. Okay, means got it now.
Now clear? So if
Yes,
the
sir.
data
Not
is not as per our model to process, so we have to make it data processing first.
yes. We have to convert it into the numerical format.
Based on the requirement, we will do those. So here the same thing, we are doing it for x-axis because y is our dependent variable, right? If you see here, y is our dependent, so this will be the input which we will give, and based on that we will predict, means our model will predict the y-axis value. Fine.
Yes, sir.
Okay, now we are using a linear regression, or we call as a simple linear regression, to training the set. So from sklearn we are referring linear underscore model. From that we are importing linear regression. We are creating a linear instance of linear regression class, and from this regressor we are fitting our x train and y train. So here we are just training it. Okay,
Yes, sir.
then we will predict it. So how we will predict it? So from predicting the test set, the same regressor which we have trained dot predict method and x test. So if you see here, we have transformed this value of x test as well. So based on that it will predict. So see what we are doing. First we segregated training and testing. So the same, one for x-axis and one for y-axis training set, and one for test set x-axis, y set test axis. And here if you see, while training we are providing x train and y train, because the variable which we have kept for x-axis and y-axis. Then we are predicting on test. So based on this it will give us the result. So which part it will predict now?
Sorry, sir. Okay. What? Yeah. It will just predict the Y part.
Okay, let me show the result so you will be able to understand it clearly. Then we visualizing the training set result. Okay, so this is for training set. Okay, so plot matplotlib which we have imported here. Okay, matplotlib. So plt.scatter x train y train we are making as a color red. So scatter plot for training data. This is for training data we are plotting. Then x train regressor we are predicting here. We are providing x train. It is for training, and we are making a color as blue. Regression line. So it will give us the line. Then title of that graph will be salary versus experience training set. X label will be year of experience, Y label will be salary, and once this thing is done, it will give us the plot. So it is for training set. Now test set, same thing, X test, Y test, color we will give red, scatter plot for test data. Now plot X train, regressor predict X train, color blue, and this thing is for title, label, and title, X label, Y label. So let me run this. So first graph is for training set. If you see, salary versus experience training set. Salary is our x-axis. So sorry, salary is our y-axis. On left side, if you see, this is our salary. On bottom, if you see, this is our x-axis, years of
Year of
experience.
experience. Yeah.
And this dot dot, it's our training data. If you see what we have scattered, X train, Y train, red, color red. So small balls dots are in red color, which is of X training and data training set for X and Y. Then what we did, X train, from X train regressor, our linear regressor, it will predict X train value and make it blue. So this is a linear line which thought to predict the correct points between X and Y. And if you see, it started from this below and it is going till top. So some of the scattering plot is close to and in between as well. So this is for training set. Now we'll come to testing set. See, for training purpose we use this data. Now how our model which we trained, it is giving us the result. So this is our testing data. Salary is our y-axis, years of experience is our x-axis, and our scatter plot, this is the test data. So if you see here, X test, Y test, color red, same thing. Then X train regressor dot predict, X dot training, based on training data it will predict and make the color blue.
Yes, sir.
And here it's giving us the title, X label, Y label, and it given us the plot. Now it is clear.
Yes, sir. Clear.
So on first graph we have trained the model, and based on
Yeah.
our training our model predicting is like this.
Output.
Okay, and once our model is trained, we provided the test data and the training model we are applying here. So it is giving, if you see, not 100% correct, but total how many data are 10 datas are there. So 1 2 3 4 5, almost we can say how much, 50% it's giving us the proper accuracy, right?
Yes, sir.
So this is a simple linear regression. So this algorithm is clear.
Yes, sir.
Any doubt, any question?
Sir, actually means if we compare it with the pre-processing, like all the steps are same only. Yeah, yeah, no, yeah, means we are just adding that what we can say like that visualization part.
No, so pre-processing, you will see common for almost all algorithm, because
Okay.
providing the data to the algorithm, we have to first pre-process it. Okay.
Yes, sir.
Without that, model will not be able to understand your data, like it is a categorical data, non-categorical data, some missing values are there or not, data is in standard format or not, right? So pre-processing is mandatory step, we can say, before applying to any model, and you will see in future also, majorly you will see these differences. Okay.
Yes, sir.
Any other question?
No, sir, no.
Okay. So let's move to the next. So this is a simple linear regression. In regression, we have many. Now we'll see polynomial regression. You heard about polynomial? It was on mathematics.
Not able to recall it, sir. No.
Okay, it's long back, maybe we missed it. So what is polynomial regression? It is an extension of linear regression. Okay, so here if you see in this graph, it is giving us a linear result. So there is not always the same case where our data will be in a linear format. It could be on many zigzag format, right? Or curve format, anything, correct?
Yes.
So it is used when relationship between independent variable and a dependent variable is not linear or it is non-linear. Okay, but can be approximated by polynomial function. So if it is non-linear, it can apply with the, means we can plot the graph with polynomial function. In polynomial regression, the curve instead of a straight line to the data. Okay, so it will be the curve. It will not be a straight line. Fine.
Yes, sir.
The example. So some of the splitting part. Here we are importing our libraries, NumPy, Pandas, Matplotlib. This library
No.
is clear, right? We
Yes,
use
sir.
Matplotlib for visualization purpose.
Visualization. Yeah.
Okay, now we have this data set. Let me check. Okay, I have imported this data set. Position salary. Then this is our independent variable x-axis, whole rows, whole column. first column values, and this is our y-axis. Let me show you this data. Okay, it's loading meanwhile. So this is our data, 3 columns: position, level, and salary. So position is in our categorical data, level and salary is in our digit. Okay, so x is our, this first column means level, till level it will be x-axis, and salary one it will treated as y-axis. Okay, y value. And if you see here, we are not training here, we are not do feature scaling, directly we are fitting the data. Okay, so linear model, we are importing linear regression, and here we are doing a linear regression instance creation. We are fitting our x value and y value directly, we are not giving a splitting part like is in training and all. Okay,
Yeah, training and
now
testing.
yeah, we are not training this model, we are directly applying it. Okay, now fitting polynomial regression to the data set. So for that we are importing polynomial features from sklearn preprocessing. Polynomial features, we are creating a polynomial feature degree 4. We'll see this degree as well. Okay, then polynomial regression fit and transform x value, x polynomial. Then this polynomial regression we are fitting x polynomial and the value of y. Then we are applying linear regression, we are fitting it. Here we are giving x and y color red. This is for plotting purpose. X linear regression dot predict, x-axis color blue, and these four are title, x label, y label. This is for linear regression. Okay, now same thing we are applying for polynomial regression. X y color red, x linear 2. So here if you see uh, x linear we have given like as a simple, and here wait, yeah, here also you can say it is polynomial function. Okay, so one is linear, one is polynomial. So regression line, linear regression to predict, polynomial regression fit and transform, color blue, and title x label, y label, and so it will show us the result. And this is for higher resolution and smoother curve. We are doing a x grid, means numpy, randomly it will take minimum x, maximum x, means from x value it will by default take the minimum x value, minimum y value, max of x 0.1. It's the difference which will x dot grid, it will reshape length. So whatever the length of x grid will be till this is the reshape one. Then plot scatter x y red color, then plot x axis, linear regression to prediction, polynomial regression, fit and transform, x grid, and color blue. And these four are like title label, x label, y label, and so. Let me run this. So let me close this one. So three graphs we are plotting here. If you see, this is for linear regression, this is for
Polynomial
polynomial,
regression.
and this is for polynomial, but more concrete data we are trying to. So this is for linear. If you see, it is not giving us the expected result, right? Our curve going in this way, but a straight line draw in such way. Then this is the polynomial. If you see, it is almost going within a curve way as our data is, right? And now it come for we, it is polynomial also, but our data set is different. So it is also going almost close to this one. So this is a polynomial function, right?
Yes, sir.
And there are two more steps: predicting a new result with linear regression. So let me run this at the end. I will keep it. So this is array value which we are predicting. Okay, what we have given here, linear regression dot predict. So value we have given is 6.5, predicting a new result based on linear regression. So if you see whatever the value which we are predicting, here we separately predicting it. So this is for linear. Now we'll see it for polynomial also. Let me run this. Fit and transform 6.5, same value. This and rerun. Okay, so this is the value for polynomial function, and earlier one which we saw, that was for linear regression. Okay, fine.
Yes, sir.
So simply if you have a data in a curve format, we can apply polynomial function. Fine.
Polynomial. Yes, yes, sir.
Okay, so this is our polynomial function, degree integer 2, interaction only, boolean false, include bias, boolean true, order string C. So generate polynomials and interaction features. Generate a new feature matrix consisting of all polynomial combinations of the features with degree less than or equal to a specified degree. For example, if an input sample is two-dimensional and of the form AB, the degree is 2. Polynomial features are 1 A B or A of 2 A B B of 2. Read more in user guide. So default is 2 you can give, so it will do the featuring like this one. Okay, 1 A B A of 2 A B, then B of 2, and min max is clear, so it will take a minimum and it will take a maximum. Let me run this with 2. Okay, so you are getting there is a slight difference, it is going out.
Yes, sir.
Okay, so that is due to the degree. Let me try to change the degree to some different angle. See how our this curve is
Yes, sir.
going.
Change. Yes.
Okay, so this is happening due to the degree. Now make a degree 4. See, it is now, it is close to that one. Okay, so you can change and degree and you can see which degree giving you is a better result. Fine.
Yes, sir.
Till here, any doubt, any question in polynomial?
No, sir. No.
Okay, we'll move to next. Then support vector regression. You heard about support vector? No?
No, sir.
Okay, let me give you a little overview. Support vector regression is a type of machine learning algorithm that is used for regression task. Okay, we are seeing only regression part now. Okay, where the goal is to predict a continuous output based on input features. It is based on support vector machine (SVM), also we call SVM algorithm, which is typically used for classification task, but SVR is adapted for regression. Okay, so this is a regression. The same thing we will see in classification also later. So small definition is clear.
Yes.
So we'll see a code. Now this is our same library: NumPy, Matplotlib, Pandas. Again we have this data set already. This is our independent variable x-axis. This is our dependent variable y-axis. We are not splitting here. Now we are doing a feature scaling. So feature scaling we are doing for x and y both. From a standard scalar, we are creating one instance for x and one instance for y. Then we are transforming the value of x, this one, and we are reshaping the value of y with underscore transform y dot reshape minus 1 to 1. Okay, then this is our SVM. From sklearn SVM we are importing SVR, it is a regressor. Then in SKR we are giving as a kernel. So there are different types of kernel also. Okay, here we are using RBF. Then regressor we are fitting x and y. So here we are fitting the SVR to the data set. Then here we are predicting it, regressor dot predict, providing a value. This is for y predict again, SVR dot inverse underscore transform, y predict dot reshape, and here we are visualizing it as we are result xy color red. It will plot it, so plt dot plot x regressor dot predict x and color blue. These are x title, x label, y label. So now here it is for higher resolution and smoother curve. So again these are random values now which we are going to pick from between x this x data set. So xgrid numpy dot arrange, minimum value we are taking from x and maximum value from x with a loop of 0.01, choice of 1.0.01 instead of 0.1 step because the data is featured scaled. Then we will reshape it length of xgrid whatever the length is, and with 1. Here is a scatter plotting x y color red. Here is a main plotting xgrid regressor dot predict xgrid value, it will make in blue. Then these four are title, x label, y label, and so let me run this. So this is the first graph, simple one, regressor. Okay, so here if you see it is going with outside or not close to dots. Then this is the another grid. Here it is also bit of close to dot or not. So like that, this is for support vector regressor. Fine.
Yes, sir.
Any question, any doubt in this? Hello.
So no, sir.
So initial part till pre-processing it will be common. Only in a
Yeah.
prediction when you apply the model, there only you have to use
You
the
just import SVR. Yeah.
uh, so let me explain some concept from this code. Okay, in the context of SVR, support vector regression, the kernel is a mathematical function. Okay, used to transform the input data into a higher dimensional feature space. So we have used the kernel, say here. Here we use the kernel. Okay. This transformation allows the algorithm to find a linear relationship in the higher dimensional space, which corresponds to a non-linear relationship in the original input space. So this kernel is for mathematical functions, okay, which can transform the input data. Fine. Hello,
Yes, sir.
am I audible? Okay.
Yeah. Yeah. I think it's net issue.
So the kernel enables SVR or SVM wherever you apply to handle non-linear relationship in the data. By using different kernels, you can control how the data is transformed and how the decision boundaries or regression line is defined. Okay, so this kernels applied on our input data to transform it to make a better relationship. Okay, now there are types of kernel.
Hello, sir.
Yeah, yeah. So type of kernels. Okay, so kernel which we saw here, we used R- RBF. Okay, this is RBF kernel, and there are many kernels type. So first one is linear kernel. So instead of RBF, you will write as a linear. So it is simplest kernel that does not perform any transformation, used when the relationship between the features and the target variable is linear. Okay. This kernel keeps the data in its original form and applies a linear regression approach. Then here is a polynomial kernel. You will write poly instead of RBF. This kernel maps the data into a higher dimensional space using polynomial functions. It can capture more complex polynomial relationship between the features in the target variable. The degree of the polynomial can be adjusted using the degree parameter we saw in the last example, right? Hello.
Yes, sir.
Okay. So with the degree, we'll be able to adjust the input degree. Then this is the RBF which we use. RBF stands for radial basis function. This is the kernel. This is the most commonly used kernel for non-linear problems. It maps the data into a higher dimensional space using Gaussian functions. The RBF kernel is effective when the relationship between features and the target is highly non-linear. So our data here is non-linear. So we applied this one. Now there is one more sigmoid kernel. This kernel uses the sigmoid function similar to the activation function used in neural network. It maps the data into higher dimensional space using a hyperbolic tangent function. It is rarely used compared to RBF or polynomials. Okay.
Sure.
When we see the neural network, na, ANN, CNN, so there we'll find this sigmoid function and activation function. Fine.
Yes, sir.
So why we use kernel in SVR? There is one more. Why we use kernel in SVR? So these are sometimes the interviewer asks such questions. Okay. In simple linear regression, you are finding a straight line that best fit the data. However, many real-world problems involves non-linear data or relationship where a straight line can't represent the data effectively. Okay, linear regression will not help every time. By applying the kernel functions, SVR can model these complex relationships by transforming the data into a higher dimensional space where a linear regression model can be applied. Fine.
Yes, sir.
This was the purpose. Due to that, we use kernel in SVR. So this code is clear.
Yes, sir.
Any doubt, any question in it?
No, sir.
Okay, we'll move to the next. Decision tree. Heard about decision tree?
Yes, it is like a true and false.
Yeah, true and false. It will create a structure in a tree format. Give you a little. A decision tree regressor is a supervised machine learning algorithm used for regression tasks. It predicts a continuous target variable by learning decision rules derived from the features of the data. Features is also known as predictor or column. Okay. The model works by splitting the dataset into subsets based on feature values, creating a tree-like structure. Okay, so this is a decision tree regressor, and we saw that random state equal to 0, right? This is a parameter is used in various machine learning algorithms like decision tree, random forest, etc. to control the randomness in the process. Okay, so I saw you like with the seed function we were able to seed the randomly generated values. So due to that we use a random state 0. So this number can vary, but by default is 0. You can make it 2, 3, 4, 5, whatever you want, but randomness will be same.
Yes, sir.
Clear concept is clear.
Yes.
Okay, now we'll see the code for decision tree regressor. This is a decision tree regression. Here we are importing NumPy, Matplotlib, and Pandas. Here we are segregating x and y axis value. So this is the independent variable. These are dependent variable. Splitting and feature scaling we are not doing here. Then fitting decisions for means we are fitting decision tree regressor data into it. So from sklearn.tree, we are importing decision tree regressor. Then for this regressor, we are giving a randomness 0, random state. And for this regressor, we are fitting x and y. It will predict regressor.predict 6.5 value we given. And here is our uh, plotting part where from numpy we are taking a minimum from x, max from y with 0.01. Then it will reshape to length of x grid and 1. It will do a scatter plotting xy. It will make in red. Then x grid regressor predict x grid and it will make in blue. These 4 lines are title, x label, y label, and so. Let me run. So this is a tree like, see, it is forming in a
Yes,
tree.
sir.
It is not in a straight line. It is not in a curve. It is in a tree format. Fine.
Yes, sir.
Any other doubt? Any other question in it? Hello.
No, sir.
No. Okay. So this is a decision tree. Okay, we'll stop here. It will be more for you. So we saw four
Yes,
algorithms
yeah.
here: simple linear regression, polynomial regression,
Polynomial
support vector regression, and decision tree one. Right?
decision tree. Yes,
I will write it here so you will be able to remember. First one we saw simple linear. Then we saw polynomial regression. Then we saw support vector. One is decision tree regression. Fine.
yes.
So sorry.
No, sir.
Okay, so pre-processing part you will see common only where it start from when we are trying to fit and train with the different models. And the same file if you see we used for these examples. Fine. So you
Yes,
go through it once. I am not giving assignment yet. Okay. So once you start doing it, we'll give the assignment for that one as well. Fine.
yes, sir.
Okay. Today we'll stop here. Thank you. Bye.
Thank you, sir.